Welcome back. Do you still remember the diagram that I showed you in the beginning about how CSS works behind the scenes? This one, right? So, we've been talking a lot about the parsing phase, but now it's time to move on to the website rendering phase. So this lecture should give you a pretty good overview about how the visual formatting model works so that you can write your code in a way that makes more sense to you. What this lecture will do is maybe not so much give you new tools, but it will summarize a lot of the CSS that you actually already know and put it in a more meaningful context. So, the CSS visual formatting model is an algorithm that calculates boxes and determines the layout of these boxes for each element in the render tree in order to determine the final layout of the page. This model is one of the fundamental concepts of CSS, which is why I decided to include it in the course. Now, in order to do this, the algorithm takes into account factors like dimensions of the boxes, which are calculated by the box model, the box type, which can be inline, block, or inline block, the positioning scheme, which includes concepts like floats and absolute or relative positioning, stacking context, the other elements that are present in the render tree, such as siblings or parents, and finally, external information such as the current viewport size, dimensions of images, or other factors. So by putting all of these factors together, the browser figures out how the final website will look for the user. So let's now look at the first four of these factors in more detail. And let's start with the box model. The box model is without a doubt one of the most fundamental parts of CSS, and it's something you really have to master in order to lay out a web page. The box model is one of the factors that define how elements are displayed on a web page and how they are sized. According to the box model, each and every element on a web page can be seen as a rectangular box, and each box can have a width, a height, a padding, margins, and a border. But note that they are all optional, so there can be boxes with no margins or no paddings at all. Now this image here shows us how the box model works. So let's break it down. First, the content of a box is where all the text, images, or other content that we specify go. We can easily define its height and width using the corresponding CSS properties, as we're going to see in the next slide. Next, the padding is a transparent area around the content, but still inside of the box. We use paddings to generate white space inside of a box, and we can define the padding by specifying the padding property in CSS, as I'm sure you already know. Next, we can specify a border for a box, and that border goes around the padding and the content. Similar to the padding, we have the margin, but instead of being inside the box, the margin is white space that's actually outside of the box itself. So we can think of margin as the space between boxes. So, for example, if we want some space between two elements, we will define their margin properties in CSS. And finally, there's something called the fill area. Remember how the text content in images go inside the content box? The same does actually not apply for background images or the background color of a box. These properties will be applied not only to the content box, but to the entire fill area, which also includes the padding and the border, but not the margin. Alright, so let's now talk about heights and width in the default box model. As I mentioned, we can specify the height and the width of an element. Now, if we choose not to specify the height or width of a certain element, the visual formatting model will just use the content of the box to determine its size. So let's now take a look at how the default box model calculates heights and width of block level boxes, and more about block level boxes or elements later. So, the width of a box, as we will see in the final layout, is defined by the right border plus the right padding plus the specified width plus the left padding plus the left border. And the same logic, of course, applies for the height of the box. But let's look at a quick example to make this more clear. Suppose we define the height for an element of 100 pixels and a padding to the top and bottom of 20 pixels. So the final height, as displayed on the website, would be 140 pixels. This means that whenever we define a width or a height of a box, the padding and border get added to what we defined. But that doesn't sound very practical, right? So the solution to fix this problem is to use the box sizing property with the value of border box. And I'm sure that many of you already know and use this trick, and I also showed it in my beginner HTML and CSS course. But it's still important to remember how this actually works. So if we set box sizing to border box, the height and the width will be defined for the entire box, including the padding and the border, and not just for the content area. What this means at the same time is that the paddings and borders that we specify will of course reduce the inner width of the content area, instead of adding them to the total height or width of an element. Alright, so if we look at the height and width calculations now, in this case, the actual total width of a box is equal to the specified width. And the same goes for the height. So if we now define some paddings or borders, they will not get added to the dimensions of the box, which makes our lives so much easier. And if we look at our example now, the final height would of course be 100 pixels, just as we specified for the height of the element. Alright, so we looked at the box model and how height and width of boxes are calculated. But this applies mainly to block level boxes, which is one of the different types of boxes in CSS. So let's now look at the three most common and most important box types, and how different box types determine how boxes are laid out on a page. Let's start with the block level box or element. We can say both. Now, first off, the type of a box is always defined by the display property, which I'm sure you know already. So in the case of the block level element, the display property is usually set to block. But please note that the values flex for flexbox layout, list item, and table also produce block level boxes. Now, all HTML elements have a default display property, and elements such as paragraphs or divs, which are usually formatted visually as blocks, have their display property set to block by default. We can always, of course, change this property manually, which can be very useful in some cases. Okay, so being a block level box, this box will always occupy as much space as possible, which is usually 100% of its parent width, and create line breaks after and before it, meaning that blocks are formatted vertically one after another. Now, about inline boxes, they are basically the opposite of block level boxes, because their content is distributed in lines, meaning that an inline box only occupies the space that its content actually needs. Therefore, they also don't cause line breaks after or another them, but instead, they just sit inside their block level parent element. Now, about the box model, things work a bit different in inline boxes. First, the height and width property do not apply, which means that we cannot use these properties here. And second, we can only specify horizontal paddings and margins on inline elements, so only on the left and on the right side. That's the way the box model works on inline elements. So of course this has some serious limitations, and in order to overcome them, there's another type of box, and that's the inline block box. Now, inline block boxes are technically also inline boxes, but which simply work as a block level box on the inside. So since they are technically inline elements, they also use up only their content space and cause no line breaks. But since they work as a block level box on the inside, the box model applies to them just like in the regular block level boxes. All we need to do in order to set an element to an inline block is to set its display property to inline block. And that's it. Very easy. So it's really important that you understand the difference between these three types of boxes so we can use them as needed in different situations. Okay, next up we have positioning schemes. And there are three of them in CSS: the normal flow, floats, and absolute positioning. And I'm sure you're already familiar with floats and absolute or relative positioning, and so this is more to bring all of these properties together into a bigger context. So, the normal flow is what happens to an element if you don't do anything to it at all, if you don't float it, and if you don't use position absolute on it. If you use position relative, then the element is still in a normal flow. And what the normal flow means is that the elements are simply laid out on the page in a natural order in the code. The next positioning scheme is when you use floats. The float property causes an element to be completely taken out of the normal flow and shifted to the left or right as far as possible, until it touches the edge of its containing box, or another floated element. When this happens, text and inline elements will wrap around the floated element. Also, when an element is floated, its container will not adjust its height to the element, which sometimes can be problematic. The usual solution to this is to use clear fixes, which I'm sure you have used when building layouts using floats, right? And then finally, there's absolute positioning. And just like with floats, when you set the position property to absolute or also to fixed, the element is taken out of the normal flow. Now, what's different here is that with absolute positioning, the element has no impact on surrounding content or elements at all. In fact, it can even overlap them. So if we want to position an absolutely positioned element on a page, we use the CSS properties top, bottom, left, and right to offset it to its relatively positioned container. Now, as I mentioned, an absolutely positioned element can overlap other elements occupying the same space. And how do we solve this? Well, CSS solves it for us actually, using something called stacking contexts. So there's one piece left in the puzzle of the visual formatting model, stacking contexts. So, stacking contexts are what determine in which order elements are rendered on the page. A new stacking context can be created by different CSS properties, where the most widely known is z-index. But there are other properties that also create new stacking contexts. Now, stacking contexts are like layers that form a stack. Layers on the bottom of the stack are painted first, and elements higher up the stack appear on top, overlapping the elements below them, just like you see on the slide. In this example, we have 3 stacking contexts, because each element uses the z-index property on an either relatively or absolutely positioned element. And that's one way of creating a new stacking context. Now, between these elements, the one with the higher z-index appears on top, and the one with the lowest z-index appears at the bottom. Now, a common misconception is that only the z-index property creates new stacking contexts, but that's not the case. An opacity value different from 1, a transform, a filter, or other properties will also create new stacking contexts. That's why sometimes, even with a z-index set on a positioned element, the stacking order doesn't work as expected. But as with everything we talked about in this section, we will see practical applications of all of this in the coding part of the course.